Now, spatial analysis steps for buffering in UpMap. Firstly, add the derived SHP data layer to the table of the content. Click Add Toolbox, Analysis Tools, Proximity, and Buffer. Set the input layer to derived SHP. Name the output features as derived buffer 300 SHP. Click Save. Linear unit as 300 and set to meters. Set the dissolve type to all and click OK. Redo this buffer but set as the default as the dissolve type and to none. The result of the dissolve type to all is displayed on the UpMap. Drag the district Kelantan to the table of the content. Next is overlay in UpMap. Open the Add Toolbox, Analysis tool and click on the overlay and click Erase. Add DSHP or derived buffer SHP to the input features. Here I name it as D. Then add derived SHP to the erase feature and click OK. So this is the result after doing the overlay. And open the Add Toolbox, Analysis tool and click on Overlay and click on Union. Add data into the features which is DSHP and District Kelantan SHP and rename the output feature class as the District Union. Then click OK. Click on the District Kelantan and open the attribute table. Now you can see the data information of the District Kelantan Union. Click Intersect at the Add Toolbox. Add the derived SHP and District Kelantan SHP into the features. Then rename the output feature class to the derived SHP District Intersect. Then click OK. Then open the attribute table to see the information about the intersect. Next, click on File and save the map. Okay, next we will do the geostatistical analysis. After connect our work folder at the folder connection, add data into the UpMap with adding the daerah SHP to the table of the content. Click Add Toolbox, click Conversion Tool, add cell to table, and import the Excel data format into the UpMap. Click on the data ground July into the input Excel file to import the data. Click OK. Click on the data ground at the table of content to display the data point. Choose E at Y field and click OK. The point on the map can be seen. Then right-click at the data ground at the table of the content into shapefile format. Click the data ground July, click data and then export data. Name as the PM10, click save and click OK. Remove the data ground July in the document at the table of the content. Next, Geostatistical analysis. Click Customize, click Extension, check the Geostatistical analysis checkbox and click Close. Then, click the Customize, Toolbars, and click the Geostatistical analysis. Click the Geostatistical wizard and then click the inverse distance weighting. Choose the PM10 for the data field. Click Next. Click Next and Finish. Then click OK. Now the inverse data distance weighting display on the ArcMap display. Then click the layers data at the table of content and click Properties. Click the Data Frame tab. Click on the Other and click the Specify Extent. Click Outline Features and choose the daerah. Then click OK. In the Clip Options section, choose No Clipping and click on the Specify Shape, Outline of Features and choose for daerah. Then click OK. Click OK. Click on the inverse distance weighting layer and click the Properties. Click Extend. Choose the rectangular extent of daerah. Click OK. Inverse distance weighting is displayed on the ArcMap display. Click the data frame in the table of the content, click Properties and click the Label tab. Choose Station at the label field and click OK. Click on the PM10 of data layer at the table of the content and click the Properties. Click the label features of the layer and click OK. Click the Geostatistical wizard on the Geostatistical tool. Click Creating. Next. Click Next. 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 And click Finish. Then click OK. Again, click Properties. Then click Extend and choose the rectangular of the daerah. Click OK. The creating was displayed. Finally, click File and save the map. Assalamualaikum warahmatullahi wabarakatuh. My name is Nazat Rusna binti Yusuf from AS2294A. Today I want to highlight the practical highlight in the lab module 3, which is Spatial and Geostatistical analysis. Okay, for the spatial analysis, first discuss on how do the result differ between dissolve all and dissolve none in buffering. When will this be important? Okay, from the picture, the dissolve all product shows buffer of individual data combined into single features, and for dissolve none, the end result shows the buffers of individual data being constant and differentiated. Overlap may occur to enlighten each features. The important based on output objective is the simple feature graphic output when they use dissolve all, and the detailed feature graphic output when they use dissolve none. Second, screen captures each overlay analysis done and explains the overlay features. First, erase, method of removing selected features and producing a new output feature class. Selected portion will be erased and a new shape class below it will be shown. For example, removing river features from map. And next is union, analytical process that combines two or more layers into single features. Overlapping and non-overlap features will be combined and shown in single polygon, but still can be differentiated. For the example, combining state area with river shape. Next is intersect, methods that enables the differentiation of the intersect features. The output of this process will show a data layer of every intersected polygon shapes of every data. For the example, finding the intersection of river and drain line flow of the area. Then, how is the XY tolerance defined in the intersect dialog? How many records does final SHP have? Okay, for the XY tolerance is the minimum distance between coordinates before they are considered equal. It can be set with desired amount based on the accuracy of choice. Now we can see the final SHP or the district intersect SHP. It contains 343 records. For the highlight all spatial analysis performed in this practical and relates the function of each analysis with real application in environmental context. In buffering, is the process of calculation and the measurement of distance outward from the direction of an object. It used in calculation for area expansion determination. It can be applied to all vector data including point, line, and polygon. For the example, buffering are used to analyze the geographic spread of rabies disease in Ukraine. For the overlay, the types of analysis that enable multiple data layers to be viewed in one output. Erase, unit, and intersect was used in this practical. Overlay enable to distinguish multiple layer features by superimpose method. For the example, overlay techniques are used to analyze the potential heavy metal pollution in China, groundwater, which use erase and intersect method. Then for the geostatistical analysis, we have tried several types of interpolation method. Screen captured the output and explain the difference between all the methods. Okay. For the inverse distance weighting, they use the deterministic method. Interpolation method shows the correlation of distance and weight towards the spatial data. Mathematical data, neighboring major values can predict the unknown value. Grid weight produces bullseye and a specific point. For cringing, geostatistical method, interpolation method shows the correlation of distance, direction, and statistical data towards the spatial data. Mathematical and statistical data, the average between points can predict the unknown value. Collected average created a polygon shape of affected area with no specific point. Second, summarize the use of geostatistical analysis used in this practical in environmental study. In the inverse distance weighting, the process that enables the prediction of unknown location using weight and distance correlation. It uses deterministic method suitable for well-distributed input dataset. For the example, inverse distance weighting methods are used in the process of digital terrain model creation. In cringing, process that enables the prediction of the unknown location using distance, direction, and statistical data. Geostatistical method, correctly used when spatially correlated distance was achieved, along with big input dataset that was not well distributed. For the example, prediction of the mechanical properties of nanomaterials.